Hello, and welcome to today's calculus lesson. We're going to talk about something called the mean value theorem. Now, mean in this case is understood to be average. It's not like the really awful, scary, terribly loud, yelling value theorem. It's the average value theorem. And what we've seen in calculus so far is there's a couple of different ways to talk about rate of change. One is average rate of change, which is just the slope between 2 points, and the other is instantaneous rate of change, which is the derivative at a point. The mean value theorem ties those two things together. So the mean value theorem says that if I have an interval, so I have a function in, from x beginning at a to x beginning at b, that's my interval. If my function is a function in x, there is some point in the interval. Now, a, b, and c, the c confuses students here. When you see a, b, and c in math, they mean some particular number for x. So if you look at the b's and the a's, that matches how our interval is defined. I take the function value at b minus the function value at a, which is just the y value at b and the y value at a over b minus a. This is just the slope between the 2 points, this part here. So you have some interval a and b, you find the y coordinates, you use the slope formula, change in y over change in x. And you get a number for that. Slope is a number, especially slope between 2 points is always a number. So, or undefined if it's vertical. But then you're going to find, now this talks about the derivative at some point c. What this is telling us is the derivative of my function at some point is going to be equal to the average rate of change in the entire interval. So the slope at one point in the interval is going to be the same as the slope on the interval for the average rate of change. That only works if the function is continuous. You can only do this if the function is continuous on a to b. There can't be any points of discontinuity in there for this to be true. But so what we do is you do step at a time. You take your interval, you find your slope, you find the derivative, set the derivative equal to the slope, and solve for the value that will make the derivative equal to the slope. Let's try this example. So I have f of x equals x cubed minus 2x squared plus 2. I'm going to calculate the average rate of change on the interval. So I did have some notes here because there's a lot of numbers here. So first I'm going to find f of negative 2. And what I found is f of negative 2 equals negative 14. And you can check this on your calculator by doing the arithmetic out by hand yourself. F of 1 equals 1. And so now the slope between the average slope on this interval, the average rate of change is going to be negative 14 minus 1 over negative 2 minus 1. And I get negative 15 divided by negative 3, which equals 5. So this part is 5 right now. Now I need to find f prime of x. That's 3x squared minus 4x. So that's 3x squared minus 4x. Now this says f prime of c, so I just changed the x to a c. Technically, if you don't do that, I'm not going to take points off. Now I want to know where that is equal to what I had over here, the 5. So I have to solve this equation. Now, that's a quadratic. Sorry for the funny circle there. So you're solving 3c squared or 3x squared, and that should be a c, minus 4c equals 5. Several ways you can do this. Usually when you solve a quadratic, you would, when you have all three terms, you would put all three terms on one side and make it equal to 0. You can use the quadratic formula. This one looks like it might factor, but it turns out it doesn't. You don't get some nice integer answer. The other way you can solve this for the zeros is by using your graphing calculator. And in your Blackboard site, I have some graphing calculator hints, and it shows you how to find the intersection, how to find the intersection of two equations, in which case one equation will be the left side, the other equation will be 0, or how to find the zeros using the intersection method, it might be labeled. But let's take a look at that. I've set that up in a graphing calculator here. And so what you see is I'm going to press y equals. Over here, I press y equals, and I put in my 3x squared minus 4x minus 5. My second, I do put in a second function, so I have something to intersect with. I want to find where this intersects with the x-axis, which is y equals 0. So then I do this second calculate. Above the trace button, you have all these calculate functions. Now, there's a calculate 0, but that doesn't really find zeros that just touch the axis, so I like to use this method of intersections where you add a function where y is equal to 0. So I'm going to do 5 intersect. And when you do that, you get this first curve. And you see you get a little cursor there. You kind of move the cursor till it's approximately where you want it. It doesn't need to be right on it. And then you hit enter. Now it says second curve. That's pretty close. Hit enter. Now it says guess. That's not your answer. You have to press enter one more time. And now it tells me the intersection is at negative 0.7863. So that is the number I'm looking for. That's where my derivative was equal to the slope I calculated. So let's go back to our document. And what I got was, if I can find where I was here, C equals negative 0.7863. Let me just check my notes, make sure I didn't miscopy that. I did that correctly. Okay, so that's how I found that 0. You can find it anyway. If you're good with a quadratic formula, that works fine for this. But using the graphing calculator to find the zeros is a useful technique to know. All right, so I did all of this in one step. I meant to write the find f prime of x down here. So this part should go here. And then part C should go under here. I apologize for doing it all in one space. So I did part B. I found the derivative up here. That goes in part B. And part C is this portion over here. So now it's interesting to see, what does this mean? Let's take a look at the graph in Desmos of this. So I asked you to graph the line. I did this in Desmos because I'm just making an observation. So it's a good use of the tool. So here is my function, f of x equals x cubed minus 3x squared plus 2. The 2 points are here and here. And you can see it shows me I've calculated those y values correctly. And then I had to draw a line between the 2 points. I just did y minus 1 equals 5 because I know the slope of the line is 5 times x minus 1. I just did the point slope form, and it actually will draw the line for me. And then I want the tangent line, the equation of the tangent line. Well, I did that by doing y minus the f coordinate at the 0.78 minus y coordinate at 0.7863, which is a little hard to see, and then equals 5 times x plus 0.7863. And you can see the black line and the blue line are essentially parallel. You get parallel lines from this, which means here's your average rate of change, and there's a point on the curve at which the slope of the tangent line is parallel. That's what you're looking for, really. Where is the tangent line parallel to the average rate of change? All right, so we're going to go back to our problem. And let's move on. So the mean value theorem says there is a point where the slope of the tangent line is equal to the average rate of change if you have a continuous function on a closed interval. Rolle's theorem, I think your book does this in the opposite order. They do Rolle's theorem first, because Rolle's theorem is a pretty useful application of the mean value theorem, really. It's kind of just a special case. Rolle's theorem is the case where you have this interval a and b, and the function values are the same at both ends, which means f of a minus f of b, or f of b minus f of a, is going to give you a 0 divided by b minus a. So that'll give you 0 for the average rate of change. So that means either the function is a horizontal line between a and b, or there is a tangent line with slope equal to 0. And in the case of a horizontal line, every point has a slope equal to 0 between a and b. There's a tangent line with the slope equal to 0 somewhere between a and b, which would indicate either your function has a relative maximum or a relative minimum, and it indicates there's at least one. There could be more than one. So when we do the practice problems, you'll see problem 1 is an example of Rolle's theorem. It's just the interval makes the function values at both ends come out the same, which means the average rate of change is 0. Okay, so we have some practice problems below, and the first one, like I said, gives us an example of Rolle's theorem. I want you to try this. I want you to stop the video, and I want you to try these problems. You're going to find the function values at each end of the interval. First of all, from 0 to pi, is sine of x continuous? Yes, it is. I didn't trick you. All of these are continuous on the intervals given, so the mean value theorem does apply. If you have a question that says, does it apply, what it's asking you to do is see if there are any discontinuities in the interval. And if you find one, then you say the mean value theorem doesn't apply. That would be something you might run into in homework. So I want you to stop the video and try this one. And then actually stop the video and you can try all 3 of these. And then when you come back, I will have the solutions presented to you. So go try them and come back. All right, I'm assuming you're back because you've done them. Now, you could have just fooled me and not done them, but you're only fooling yourself. Let's do problem number 1 here. Let me pick a different pen this time. No, let's work with the black one. Okay, so I have the interval from 0 to pi, so I need to find f of 0, and that is going to be the sine of 0, which is 0. I should know that from my pre-calculus, my trigonometry. F of pi, 0 and pi are both on the x-axis of the coordinate plane or of the unit circle, and sine is the y-coordinate of the unit circle, so if you're on the x-axis, the y-coordinate is 0. So both of those are 0. So my average rate of change is 0. 0 minus 0 over pi minus 0 is going to give me 0. So that's why this is a case of Rolle's theorem. So now I want to find f prime of x. My function is sine of x, so f prime of x is cosine of x. And now I want to find out what number for c, or you could leave that as an x if that's confusing you, is equal to 0. So I want to solve this. I have to solve this for c. So the cosine of c, the cosine of what angle equals 0? And that angle has to be on this interval 0 to pi. Okay, when we did the previous problem, when you look for zeros on the function in the calculator, set your x min and your x max to be just a little lower than the left end and a little higher than the right end. You don't need to look for any others. There are many angles that have a cosine of 0, but we only care about the one between 0 and pi. And if I can even just straight out remember this from trigonometry, 90 degrees or pi over 2 radians. And remember, in calculus, we're always in radians. So if you're graphing things and it's looking funny and you have trig functions, make sure you're in radian mode. So c is pi over 2. So this is the value that satisfies, the point that satisfies the mean value theorem. Now, they asked for the point, so I might also want to find the y-coordinate. Sine of pi over 2. Sine of pi over 2 is 1. So it would be the point. The point that answers the question would be x is pi over 2. F of x is 1. This would actually be the answer if they're looking for a point. But if they just say where, then they're just looking for the x-coordinate pi over 2. All right, so if you did problem number 2, if you didn't do problem 2 yet, stop this. I'm about to go on and do problem 2. In problem 2, we have a cubic polynomial. We start at a is 5 and b is 10. So I calculate f of 5 and I calculate f of 10. And I did this out on my paper, so I'm going to take a look at my notes here. And f of 5 came out to be 361. Pretty big number there. And f of 10 came out to be 2,921. So to find the slope, the average rate of change, that's what I'm finding. I do 2,921 minus 361. And since I started with the 2,921, I do 10 first on the bottom. 10 minus 5. And when I do that arithmetic out, I get, what did I get? I get 512. So my slope is 512. That's pretty darn steep. So from 5 to 10, that's a very steep line. But that doesn't matter. I can still do this. So I find f prime of x. That equals 9x squared minus 2x plus 2. And I have to set that equal to 512. So this is what I'm solving. I should really substitute that x, make it a c, but it doesn't really matter for getting the solution. I will not grade that as wrong if you leave it an x. So when I solve that, what I did was I did 9x squared minus 2x minus 500 in 10 equals 0. Actually, I think I did minus 500, which would be wrong. Minus 510 equals 0. And if I want to do that on my calculator, I will go do that right now. I got to go to y equals. Now I'm going to do 9x squared minus 2x, so that becomes a 9, and then I can go over there and make that a 2, and I'm going to have 510. When I did my workout, I for some reason had that as only 500. Minus 510. Now, these are big numbers. When I graph this, well, let's set my x window. I'm going from 5 to 10 in this problem, so I want to set x min to be negative 5 point. Sorry, not negative. I want to set it to be 4.9. Positive 4.9, because I need to go just a little bit below 5. And then x max just a little bit above 10, because I don't want to see all sorts of other solutions. But when I graph that, now notice I have y min negative 10 to 10. I'm going to graph that. And I do see this. I don't see much of the other curve, but if I choose those x's correctly, I can see where it crosses the x-axis. Now you'll notice in y2 still had this equals 0. If you're getting no second curve or some error, sometimes people forget that. So I'm going to go back to my graph, and I hit second, and then I hit the trace key. So the second will give me the calculate menu, and I pick 5 for intersection. And again, I get that first curve. I see y equals negative 18. It looks like I need to move this way to the right. There we go. I see the cursor. I'm just going to hit enter once I see it. Enter again, and then enter the third time. And I get 7.6396 or 7.64. We'll leave it. So let's go back to our Word document, and we get x equals 7.64. And sometimes there will be 2 answers in the interval. Sometimes you'll find multiple points where the tangent line is equal if the interval includes a turnaround in it. But in both of these examples so far, all of the examples we've seen, there's only been one. The mean value theorem guarantees there's at least one. All right, and for the third example, we have kind of a classic projectile motion thing, although I picked a funny interval. You're looking at negative 4.9t squared plus 10t plus 50 from 0 to 10. So I find, and this time I used t, x is my position function, x of 0 equals 50, and x of 10 equals, and I did do this out already, x of 10 equals negative 340. And when I do the slope, I do negative 340 minus 50 over negative 390, over 10 minus 0, which will give me negative 390 over 10, which is negative 39. And then this one ends up being a little easier to solve because x prime of t, sorry, I'm not going to bother erasing that, I'm just going to do that, x prime of t comes out linear, negative 9.8t plus 10. So I want to know where is negative 9.8c plus 10 equal to negative 39. Where is this derivative equal to the average rate of change? And I get negative 9.8c equals negative 49. And that's a point. Negative 9, sorry, you divide both sides by negative 9, you get c equals negative 49 over negative 9.8. It's good. I get a positive value because my interval is from 0 to 10, so I would hope so. And I get c equals 5. That's the So if I want to find the point that satisfies the mean value theorem, and I might not have finished this in the last one, negative 4.9 times 25, which is 5 squared, plus 10 times 5, plus 50, plus 50, and that will give me the y-coordinate of the point. And 5, comma, the result of this gives you the point. Okay, I hope that gets you started on your homework and understanding the mean value theorem. It's not the hardest thing we've done all semester. It's not the most difficult concept. It's just if you don't know how to do it and how to get it started, it's impossible. So hopefully this gets you started, and doing a couple problems gets you understanding it. All right, please email me your questions, and thank you for watching.